Okay, so we're going to pick up where we left off in the example on Monday and continue to read through this cities.csv file and process it into countries with all of the cities in that country. So a reminder, let's close a bunch of this stuff. So a reminder, this is the data that we're parsing. We have each line containing a city which has multiple values. It has the 2-digit country code, the name of the country, a 2-digit region code, the population of the city, and then the latitude and longitude. And we want to parse these lines. So far, we've opened the file. We've taken our file name, opened it, read all the lines of it. That returns a list. We jam that into an array list just because we're used to working with array lists. And then we're iterating over each line of the file. This array list is going to contain strings, where each string is a single line of the file. And we want to parse all these lines. Whenever I'm parsing lines like this, for what it's worth, I like to paste a sample line from the file right in my code, so I don't have to keep switching back and forth from the file to my code and continuously look up that file to remind myself what the format is. I'll put a line right there, and then if I ever want to change this code in the future, I might come back to this a month or a year or several years later. I have that sample right there. I don't have to go digging up the file, a sample file or anything. I have an example of the code right there. So we have the line, and the first thing we want to do is split this line on commas. Remember, this isn't the way we should parse CSV files. We're just simplifying things for 116 for your second semester. But line.split on commas. That's going to give us the values. We have comma-separated values. We're going to look for the commas and separate the values in this CSV format. CSV is a little more complicated than this. If there are commas contained in the data itself, those commas have to be escaped with double quotes, and then if there are double quotes in escaped data, those double quotes have to be escaped. It gets a little more complicated, but we're going to keep it simple and just only use data that does not contain commas for this course. This is going to give us, and we want this in an array list. It's not going to give us an array list of string, which will be the splits of that line. But split returns an array, and we just don't want to mess with arrays. Unless you want to mess with arrays, I'm not going to stop you. But we don't want to mess with arrays necessarily. But the split method will return a plain old array of strings with this syntax, and then you can get the values at indices and do some of the array list stuff with an array. But you have a lot of extra functionality that an array list builds on top of an array. And if we look at our array list class, we can see that what it does, if I can find it fast enough, what it does is actually uses an array underneath the hood. So there is an array that we are using, but array list gives us a lot of functionality around that array, so we don't have to mess with the difficulty, I guess. The difficulty of using a plain old array. And don't worry, in 220 and 250 both, you'll be using plain old arrays. You'll get a lot of practice with these and a lot of understanding of what they are next semester. We don't have to jump into that in 116. The short answer, and we've talked about this just briefly in the past, the short answer is arrays are sequential data structures that are one big chunk of memory that can't change size ever. If you create an array of size 5, that will always be an array of size 5. You can't change it. You could destroy it and create a new one with a different size, but you can't change the size of an array. It can never be an array of size 4 or an array of size 6. Can't happen. It's always going to be an array of size 5, which is a pretty tough restriction to work with. You can't add, like an array list, we like to call the add method and just add things to our data structure. Can't do that with an array. So instead of messing with that, we're going to convert that to a list. And we've used the same syntax to give a comma-separated list of values into our array list. We would say arrays.asList. This is going to take any number of values, either separated by commas, or it'll take a plain array, and then it'll convert that into a list. It'll change that into an array list. Incidentally, it uses, it creates an array list, but returns a value of type list, which, is that true? But it's not public. Oh, I see. So array list actually has a constructor that today I learned. Array list does have a constructor that just takes an array, so we could skip one step out of this, but it's not public, so we can't use it. So close. So we're going to create this as a list, which happens to actually be an array list, but since it returns a list, we're going to create a new array list and then not worry about the array interface. We'll talk about, I forgot my type, and we'll talk about interfaces next time. List is just an interface. It's extended. I can show you that much at least. Array list extends collection, which extends iterable. Maybe I missed it. Well, here we go. Implements the list interface. So we can store an array list in a variable of type list. That's something called polymorphism. That's all about next week. This implements interfaces. List is an interface. All that stuff's topics for next week. So for now, we'll just throw our list into an array list and then use it that way. Because we're used to array lists, right? We like array lists. So now that we have the pieces of this line in an array list, we can start accessing the values and extract the information that we want out of the array list. So if I want, which I do, the country, that's going to be the first value from this array list. So I'm going to do splits.get of 0. And that's going to give me this first value out of this line. After I took this line from the file, split it on commas, and get the value at index 0 after splitting it, that's going to give me this value, whatever comes before the first comma. I'm going to do the same thing for the rest of the data. I'm going to get the name of the city, the region code, the population, the latitude, and finally the longitude. Update my indices here. So for example, the longitude is the value at index 5. 0, 1, 2, 3, 4, 5. After splitting on commas. So I get all my information. One thing here, population, latitude, and longitude are numbers. When we create our city class, actually let me do this out of order a little bit. When I create my city, one, I have to be careful with the order. So I'm going to look at my constructor parameters and make sure I get things in the right order. So the first thing in our file is the country, but the first thing in our city constructor is the name of the city. So don't just go in order from the CSV file and then just jam things into the constructor of the object you're creating. This is a common thing that I see whenever we're reading files like this in office hours. It's a common question, not really a question, but a common, why doesn't this work? And then that happens to be the answer. And then the student always feels bad after that one. Oh man, it was just the order of things. But the order that I'm reading from the file is not the same order as the constructor. So I'm going to make sure that the order matches, especially in a case like this where I have 3 strings. Let me get my city class open just so we can visualize that. So we have 3 strings, the name, region, and country. And I want to make sure these 3 strings are in the right order because the compiler's not going to yell at me if I get the wrong order here. The compiler's not going to care that I have the string of a country code where I should have the string of the name of the city. The compiler won't know that. So we're not going to get help there. And this happens to be the same setup as the songs. You're going to read the ratings.csv in task 7 and read those song values, but the song constructor doesn't take the values, those 3 strings, title, artist, and ID, doesn't take them in the same order that they're given in the CSV file. So keeping track of that order is going to be important. So let me get my helper bubble here. So name, then region, then country, then population, then covering up all my stuff. Population, then latitude, then longitude. We're going to get some errors here, which is fine. Well, not fine, but we're going to fix it. We expect these. So we get errors because we read population, latitude, and longitude as strings, but population, latitude, and longitude are an int and two doubles. So we need to convert these into the right types. I need a string. I need an int double double, but I gave string string string. So as we saw last time, we're going to convert these to the right values using the corresponding methods. So let me get the variables in the right values, and then to convert a string to an integer, integer.parseInt, and then double.parseDouble. Oh my goodness. Parse double. So now we have the values in the right format. These methods are going to take in a string and then return whatever value we asked it to parse. ParseInt is going to return an int, and it's going to go through the characters of the string and interpret them as integer values, and then form the int that we expect. If the string is not well formed, well, I can go back in the method and show you. If it's not well formed, it's going to throw a number format exception. Just like reading the file is going to throw an IO exception if something goes wrong, this is going to throw a number format exception, which is an exception we don't have to catch. We could catch it if we wanted to. But now we have all the data in the right format. We created a city object. I'm going to store this in a variable. And now we want to get this city in our hash map. Our ultimate goal is to return a hash map, mapping the mapping the country codes as strings to an array list of all the cities in that country. That's our ultimate goal. What throw's doing, that's going to throw an exception. And if that exception isn't caught, like we're not catching that exception at all, it's going to crash our program if we ever get a number format exception, which we actually will. As opposed to catching the exception, we're catching an IO exception. So if we open a file that doesn't exist, we're going to return an empty hash map because we're catching that exception. We're not catching the number format exception that's being thrown, which we could actually catch it. I mentioned last time we can have multiple catch blocks. We can actually catch that thing. If we wanted to. If you want to be fault tolerant, if you expect to sometimes get malformed strings, you can catch that and then handle it however you want. Maybe put a population of 0 as a placeholder if you can't read the population, for example. But in general, that means that this is a dangerous method, that this method might crash your program if you call it. So we have the city. We want to get this into our hash map. And we're going to do something, the vocab for this one isn't really important, but we're going to do something called lazy initialization in our hash map. So our hash map might or might not contain the country of this city. And we're going to check if it does, and only if the country hasn't been seen before, if it's the first time seeing a country, we're going to initialize the array list in the hash map. So as opposed to something that's not lazy initialization, would be like going through the entire file, looking up all the countries, storing all the unique countries in an array list, and then iterating over that array list and initializing the hash map for each of those countries, and then reading the file again, actually populating the cities in those array lists. Here we're just going to say, well, if we haven't seen this city before, we'll initialize it. So we're initializing things at the last possible moment, the laziest way to do things, just waiting until the last possible moment and then initializing them. which is usually a lot more efficient to do lazy initialization. So we're going to say if this country's hash map, countries.contains key, is going to return a Boolean of whether or not that key exists in this hash map. I'm going to check if it contains the country of this city. And more specifically, I'm going to check if it does not contain this country. So if the hash map does not contain this country, I want to initialize the hash map for this country by adding a key value pair for this country. So countries.put, I'm going to add a key value pair to this map. The string is country, and I'm going to initialize it to a new A. I swear, Paul named a class A in the repo, so now my autocomplete for array list usually gives me that class. So I'm going to initialize that country to an empty array list. So if this is the first time I've seen this country, initialize the hash map for this country, the key value pair for this country, to be an empty array list. It's the only time I'm creating a new array list in this hash map. And then whether this is the first time I've seen the country or not, so if it's the first time, it was initialized. If this is not the first time, this code doesn't run. It doesn't do anything inside the conditional. So no matter what case this is, I'm going to go to my country's hash map, and I'm going to add this city to the appropriate array list. This is where understanding references is going to pay off for us, to see what happens in this next line, how to get this city in the right array list. So we're going to go to our country's hash map. We're going to do .get of the country to get the value at this country. This is a hash map of string to array list. So when I do .get and give it a string, it's going to return a reference to an array list on the heap. It gives me a reference to an array list, and specifically a reference to the array list for the country represented by the string I gave it. So this expression evaluates to a reference to an array list. I'll use my dot operator to head over to that array list on the heap, and then call the add method at that array list, on that array list as the calling object, and add the city to it. And that's it. That's our method. We already have the structure around this, so we're returning countries at the end. I set that up first on Monday. If the file doesn't exist, we're returning an empty hash map. And and each time we're reading a line, we're going to add that city where it belongs in the hash map while initializing a country if it's the first time we've seen a particular country. Who thinks this code is going to work? I don't think it is. I'm not so sure it's going to work, but let's try. Let's run it. And it crashed. Crap. So we talked about exceptions last time, and you've seen these tons of times. We see these errors all the time when we're writing code. It's just part of the debug process. But now that we talked about exceptions, we know a little bit more about what this is telling us. And we can read these error messages a little more wisely. I don't know. But we can see what this is telling us. So it's saying an exception was thrown. It's a java.lang.number format exception. And then it even gives us a little bit of output. This exception gives us some extra information for input string population. So it's saying we're trying to turn the string population into a number. And then it gives us the stack trace. This is each method that was on the stack when this exception was thrown. And we know that none of these methods caught the exception because it bubbled up to the main method and then blew up the program. But for input string, this method threw the exception. It was called by parseInt. Another parseInt, most certainly an overloaded method, were both on the stack. And then the first method that was on the stack that we care about, these top three are controlled by Java. First one we care about was the load countries method. Did see this exception. And each stack frame is reporting which line it was running when the exception was thrown. So load countries was running line 26 when the exception was thrown, and the main method was running line 53 when the exception was thrown. Since we got all the way up to main and main didn't catch the exception either, program crashed. So when we see these, generally we look for the top blue link. That's the first one that we care about. And this is the line that saw the exception, even though it was thrown by internal Java code. This is the line that we care about that caused the issue. This integer.parseInt splits.get3. And we can see where the main method is on the stack. Of course, it's calling load countries right now at this point. But that's what all this information is telling us. And if we really want, you can go into the Java code that actually blew up. We can see how it's converting strings to integers. And then it threw this exception, through the number format exception. While it was, here's the actual code that's doing this stuff. So this is actually parsing the string into an int. And right when it was doing this, threw an exception. So that's what happened, or that's what this is telling us anyway. So let's go to the line of code. I want more information for my money. So I'm going to set a breakpoint on this line that blew up, this line that caused the issue, the last line in our code that caused the issue, and then run this in the debugger and see if we can get some more information out of this. So I'm going to run the debugger. It's going to stop at that breakpoint, and I can see the line that's being processed when this exception was thrown. Well, it happens to be the first line, so I don't have to go digging to find the line. But the first time we hit this line of code is on the problem line. It's the line with this information. If we go to our cities.csv, we go, oh yeah, there was a header line on this file. So we're trying to parse the header line, and when we get to the string population, we're trying to parse that as an int, and the string population is not a well-formed int, so things blow up. We can't parse that line. We could actually catch the error, catch the exception, like I showed a little bit ago. But at any rate, we have to handle this situation one way or another. We saw the bug, we found the bug with the debugger. Now we have to write some code to fix the bug. For what it's worth, and whenever you have header lines, you have to do something to handle the header lines in any data file that has them. For what it's worth, task 7, the two file formats that you have to parse don't have headers, so not something you have to necessarily worry about. Well, I don't know why I say necessarily. Something you won't have to worry about in task 7. But in the real world, you'll definitely have to handle that. So let's go to our code. And there are several ways to do this, to handle the header line. I did it a different way in the first lecture. Let me do it a different way in this section. Maybe I'll do it a third way in the other section. I'm going to say if line dot equals the header line. Oh, with a trailing new line, that's bad. I'm going to say if I'm looking at the header line, continue, which is a keyword I don't think we didn't talk about it in 116. I don't think they talk about it in 115. Maybe they do. But continue, when used inside of a loop, this keyword is going to skip the rest of the loop for this iteration and then go on to the next iteration of the loop. So if line equals this, we're going to skip to the end of the loop and then go to the next line in the file. So in this code, we're effectively skipping this line in the file. So if we see the header line, skip it. Move on to the next line in the file, and we're effectively starting at line 2 of the file this way. So there are a lot of different ways to handle this. I like this way for what it's worth. How do we handle multiple header lines? You could do another if. You could do like an else if, and then line dot equals whatever the second header line is, and add them all. Or the way that I did this in the other lecture, just so you can see it too, is I did lines dot remove. This takes an index. Remove the value at index 0, and that's going to skip the header line. So if I wanted to remove multiple header lines, I would do lines.remove index 0 again, because the new index 0 is going to be the second line of the file. The reason I don't like this so much, and it bugged some students in the previous lecture, is it should bug you as well. It's very inefficient. I have an array list of size almost 48,000, and I'm deleting the first element in the array list. That means almost 48,000 values have to be moved down by one index. 48,000 values have to be rearranged in memory, which takes a little bit of time. I mean, a fraction of a second. That's still a tiny number to our computers. But if you get in a habit of doing things like that, eventually all that slowdown is going to add up, especially if you're working with larger data sets. That will add up, and you will get a huge performance hit in your code. And you'll be writing really slow, crappy code if you keep doing things like that. Whereas if we're checking the line and then continuing, it's still a little bit of a performance hit because we have to run this check. I keep forgetting the number, 48,000 times. So if anything that's slow inside this loop will get multiplied by 48,000. So if we do something that takes 1 millisecond, it's going to add up to 4.8 seconds. I did my math right there, right? If anything takes a full millisecond inside this loop, that adds up quick. Luckily, a millisecond's a long time. Writing code that takes a full millisecond inside of the loop is really bad code. Depending on the application, I guess. For this application, that's really bad code. So we're skipping the header line. Let's run this again. Let's stop the debugger. Run this and see what we get. See if we get things working the way we want it to. And we do. Maybe. Maybe we do. But this is our output. It's all of the data, it should be, if everything's working right. It's all of the data in that cities.csv file. You can see my bar on the side here barely moved after all that scrolling. Do we know that this is right? Am I going to look through this and make sure it has all of the data that I have in the file? I don't think so. I'm not doing that. So our next thing is, how do we test these things? When we have file I/O, or at least file input, we're reading files with lots of data. How do we make sure that we have the right stuff, that we're actually doing the right thing? And that gets tough. We're not really going to be able to do it for this application anyway, where we're returning all of the data. We won't write a test case for all 48,000 cities, making sure that we have all of the correct data. What we want to do is generate smaller test cases by creating files similar to this one in the same format, but with significantly less data. And it's useful to use our real-life data when we're doing this. So we want to use real data, but we want to find some subset of this information to be able to use for our testing purposes. Now, for task 7, if you just go to the data file and grab a couple lines and use those as your test case, fine. That's no big deal. But what we're going to do in lecture is find a way to find just small cities from this file. Instead of scrolling through this and trying to find cities that just have a couple of, or countries that just have a couple of cities, we're going to write some code that's going to find those small countries for us and then use those countries to generate our test cases. So our test files will have entire countries of cities, of real data, and then use those for our tests. And with the emphasis on real data, if you write your own test, when you write your own test cases, like for task 4, a lot of your test cases probably followed certain patterns. Whenever we, as humans, generate random-ish data, we tend to follow patterns. Like whenever I am coding in lecture and I have to come up with a test case that takes integers, testing a method that takes integers, I'll always generate integers that are very similar to each other. I'm always going to do like 0, 1, 2, and like 100 or 200 and 1,000 and negative 1,000. I always end up coming up with very similar things, and I assume that all of you do too. It's just a human nature to follow patterns. So when you generate your test cases, you probably have like song 1, artist 1, or a couple of whatever songs you're listening to at the time. Some of you do actually code up actual song names, or but then even when it comes to the ratings and the rater IDs, you're going to come up with a lot of the same values each time you come up with test cases. If you have real-life data, real-world data, it's going to expose some bugs that you might not have exposed when you're generating your own test cases. So when you have when you have fake data, it's probably not going to look anything like this. It's not going to quite look like that at all. So if you're testing on real data, it has a tendency to expose some bugs that you won't expose when you're using fake generated data, fake inputs. Plus, it's easier to generate data when it's real data. You just go grab the data. You don't have to sit there and think of a bunch of test cases. So let's write some code that's going to find the countries. I want to write a method that's going to find the countries that contain three or fewer cities. That's what I want to write. So let's do exactly that. So I'll make this private because why not? Static. The way I'm going to write this, I'm going to make it void. Filter countries, which is going to take a hash map of string to array of city. Countries. And I want to filter this down to just the countries with three or fewer cities. And then instead of returning something, I'm going to print them to the screen. So I'll set up an array list, which is going to have my answers in it. String, this will be all the small countries by their country code. Small countries equals new array list. I'm going to have some threshold so I can easily modify my code later if I decide I don't want all the countries with 3 or fewer cities, I want all the countries with 10 or fewer cities. I'm just going to change this int one place, and it'll be easy to make that change. And I want to iterate through my countries for country in countries.keyset. So for each country code, countries dot get country dot size less than or equal to threshold if small countries dot add that country. So countries.get of a country, this, again, just like we saw last time, this resolves to a reference to an array list. I'm going to head over to that array list on the heap and ask it for its size. If that size is less than or equal to my threshold, I got myself a small country, and I'm going to add it to my small countries array list. And then I'll iterate over my small countries. Oh. It's an opportunity to show something, actually. So I spelled countries wrong here. If I right-click this and go to refactor and rename, add my n, it'll add it in every instance of that variable. So I don't have to go chase down every instance of the variable. Here it was only 2 instances, so I was fine not using that. I was just going to manually fix it. But when I have a variable that I've used 20 times throughout a method, or if it's an instance variable that I've used throughout 100 different methods, or something I've used a lot, like for, or even a method name. So for example, you forgot like a capitalization in one of your method names. You submit to Autolab, you're getting errors, and maybe you go to office hours or run that's not a debugger thing. But somehow you find the issue, and you have this method that you have all throughout your tests. It's like the get song list method, and you have 20 tests, you call it all over the place, and you got to fix this capitalization all over the place. Just right-click, refactor, fix it once, and IntelliJ is going to fix it all throughout your code, even if you use it in different files. Refactoring, useful tool. So for string country in small countries, you know what? We're ready for this one, right? We can do a lot in one line these days, right? For countries .get, so I'm going to get the array list of cities for this country. Get country for city in that array list. Actually, that's not even that bad of a line. I'm going to print out the city. So I'm just going to print out all the cities for the countries that have 3 or fewer cities. Let's change our main method here. Filter countries actual. And let's rerun main and get just these small countries printed to the screen. But it's still going to be a bit of a mess. This is kind of hard to read still. Plus, it doesn't help us. Our ultimate goal is to use this code to generate test cases that are more manageable. So we are going to have to hard code our expected output. And that's not even what I was trying to say. We're going to have to generate a file with this data. So we don't want to manually create a file with this data because that's kind of a pain. We got to get it in this format. So what I'm going to get, we'll pick on Tacoma here. What I want to do to make my life easier is rewrite this toString method to print out cities in the same format as they appear in the file. So again, just like reading the file, when I'm writing contents for a file, I want to paste the format that I expect and then rewrite this to be in that format. So country code is first, this dot country, comma, this dot name, this dot region, this dot population, this dot latitude, this dot longitude. So I'm just going to format, right in my CSV format in the toString, then rerun this code, and then we can finally get to something a bit more manageable. So now we get the data in that format that we're working with this whole time. And we can see all the countries that have 3 or fewer cities, which, yeah. Oh, thank you. Latitude, longitude. Yeah, they're all the same. Thank you. So now this is more manageable. It's still a lot. These are still a lot of cities. Actually, let's do something since we set this up. Let's change this threshold to be 2. So we'll get all the cities, all the countries with 2 or fewer cities, which is still going to be a bit much. And then when we want to generate our actual test case, I'm not even going to take all this data. I'm just going to take a small sample of this data. I'll get 1 country with 1 city and 1 country with 2 cities, which is a good enough starter test case. We would want a bigger test case after this, but this is a good start for us. We could even start with just 1 and then do the just 2. Let's go right for all 3. One I had in the other lecture. So I'm going to go to my data folder. I'm going to create a new file. And for Task 7, you'll create your own test files. I'm going to create a file, which I'll call city test. I think that's what I called the other one that I just deleted. citytest.csv. And I'm going to paste that data right in this file. And then I open up all these Java classes. And that's not quite enough. We got one more step to do. Again, you don't have header lines in your homework, Task 7 stuff. But we have a header line here, so we want to make sure the file is in the right format that we're expecting, especially if somebody has that line of code where they just remove or ignore the first line of the file, no matter what it is. If they're expecting that to be a header line, we need to have that header line there. We can't have them removing a line of actual data. That's just asking for bugs. So when we create our test file, we'll make sure that header line is there. So we have the right format of our file. And this file is in data/city test. So when we're setting up our test case for this, our file name is going to be data/citytest.csv. So we want to make sure we have the full path in the file name. Do not fall into the trap of hard-coding any of the file name in your code. What I'll see a lot of students do is like string full file name equals data/ plus file name. I'll see this a lot of the time because they're like, well, you told us that all the files had to be in a directory named data, so I'm going to add the directory to the file name, which I see the logic. It makes sense. I'm not saying it's the wrong thought process, but it's not what the file name is here. The file name is the full path to the file containing the directory and everything. So do not do this. Even worse, I'll see some students say, well, the file name was cities.csv, so this is cities.csv, and completely ignore the parameter. Don't fall into that trap either, please. These are both issues that are, you'll get it to work on your laptop because you'll just make sure the paths are right. You'll make sure the file names exist and everything. Then you submit to AutoLab and you'll get all kinds of errors. It's one of those issues that are, that almost, if you have that issue, you almost have to go to office hours and talk to a TA. So please avoid those issues. The file name, just take that straight up. And then in your test, your file name should have data/file name. And your file should be in that data directory. If you have it set up like that, you won't have those types of issues when you submit to AutoLab. So hopefully we can all avoid those issues. I would love it if I didn't see that issue at all this semester. And then I want to get my actual. So hash map of string to array list of city. Actual equals, I would keep forgetting what this is called. Country example load countries file name. So that's going to give us the actual output, and then we want to generate our expected output. Just like all of our testing, when you have expected with file I/O, you don't want to read the file. You don't want to go to the file at all when you're generating your expected. You want to hard code this to make sure that there's no issues with this. Just like before, if we're writing code to read the file to generate our expected output, we're using code that reads the file to test code that reads the file. If you made the same mistake in both places, you're never going to find that mistake. We want to hard code our expected to make sure that we don't have issues like that. So this is a new hash map. Not to say that we don't use that data. I am going to use it. Just like before, I'm going to cut and paste my data. This helps me in a few ways. I'm going to cut and paste my data right here. So when I'm generating my expected output, I have the data right there to refer to. I'm going to do a bunch of cut and pasting. And also, if this test fails, I don't have to keep going to the file to check what the contents are. I have all the contents right here, so it's easy to see quickly if something went wrong. So expected. No, the data directory is not in the source. It's outside of source. It's at the same level as source. It's very important, too, because I see that quite a bit, too. If you put the data, you'll catch that. If you have your file name set up in your test case just like this, you'll be able to catch those things. If you put data inside source, you'll have src/data right here, which won't work for you. It's gonna mess up in AutoLab. AutoLab's looking for that, expecting it to be next to source, not in source. If it's in source, everything will be jacked up like that. Expected.put, so we want to add key value pairs to this map. Can I go over how to make the data folder? Sure. You go to your top level directory of your project, right click, new directory. name it data. It won't let me do it because I already have a data folder, but that's right-click, new directory, and then name it data. And then you'll copy your files, all your test files, you'll store in that directory. So we'll put KR, new array list, arrays.as list, new city, and this contains one city, Saul. I'm going to be careful with my order of my parameters. It goes name of the country, then region, I believe. Well, now I have to look. Region, then country. Region is 1 as a string, and country is KR. Country code for Korea. No, that can't be. No. I don't know enough geography. Population, lat long. Set up PM. It's going to be an array list with the cities for this country, 00. Sorry, I don't know my country codes that well. And get this data where it needs to go. Bear with me, I just got to cut and paste some stuff here. Even though we're only using 3 cities, it's still a little bit of tedium to get this where it goes. Those have the same region, so we're good there. And we have our expected all set up. We have all the data exactly as we expect it to be returned from our method. And then we have the task of checking the hash map, making sure these 2 hash maps have the same values. So when we're checking any data structure, first thing we want to do, and we'll finish this up on Friday. We're going to run out of time here. First thing we want to do is, it's probably the only thing we'll get to do here. We're going to, if I can type, my goodness, expected, check the size.